Hello everyone. Today is day 29 of our challenge of solving 30 problems in 30 days. So let's start and see what the problem is. So the problem is credit risk prediction and with logistic regression and SVM. We have built projects, small projects or solve problems on both the models before, so it is not going to be a big challenge. So let's get started. The flow is going to be same. We'll go and use chat gpt, ask questions, ask whatever is not clear to us. And yes, so let's get started. I'll say, hey, today is day 29 and here is the problem. So it says we can use this credit card data. We can get this data from Kaggle. Let's say we get this data from Kaggle. Yes, there is a data set. We can download the data set maybe from UCI machine learning repository. Download this German credit card data, and I should be able to done. I'll unzip it, go here, and we'll move this out. Sorry, this data out. It is in which format? It is in data format, right? We need the CSV. And if I go here, mm, I do see the data. German credit card data contains 1,000 entries with 20 categorical symbolic attributes prepared by the Professor Hoffman. In this data set, each entry represents a person who takes a credit by the bank. Each person is classified as good or bad credit risk according to the set of attributes. The link to the original dataset can be found below. So I am going to go and download this. This looks in CSV. That's why I am downloading this. I should have this data. Yes. I'll go and move this from the downloads folder to our dataset folder. Let's go do what? Let's create a file for today's problem, and it is going to be a Python file with name day29.py. Add it to our Git repository. The problem, let's mention what the problem is for today. Go here, copy it, go here, and then do what? Mention where are we getting the data set from. We have got the data set from this problem. Now we will do what? Import some libraries to get started called as Panda first. Then the step number one is load the data, and we will load the data how? We will load the data from this and store in the data and use the pd.read csv, mention the location which is data set in our case, and here the German credit card data.csv. Let's see what how this data looks like from the info method. Also print couple of rows from the head method. Let's clear the terminal, run this 29 day 29 file, and this is how the data looks. It has how many columns? It has 1000 entries, that is 1000 rows, and 10 columns. 10 columns look like this: age, sex, job, housing, saving accounts, checking account, credit amount, duration, and purpose. And this is the, and we have one, two, three, four, five type of categorical data I see. Then the purpose is radio/TV, um, education. So we have purpose also. Uh, okay, I'm just thinking which one is going to be the target here. So yes, this is how the data looks like. So I'm going to copy it and go and share it with the ChatGPT. Hey, I have downloaded the data set and here from Cattle, and here is how it looks. Yes, so we'll have to handle missing values. Then we have to fill the missing values from the savings account, checking account. Then we may have to convert the categorical data into numeric by using one hot encoding. So yes, and then we will see how the data looks like. And then we will also define the feature and the target. Feature is going to be risk. Why do we have any risk data? We don't have the risk, right? Acha, if the credit amount is greater than 500, we have to do what? Credit risk prediction. And data duration is okay. If the credit amount, define a simple rule to generate the risk. Okay, if the credit amount is fine. Hmm. If the credit amount is more than 5,000 and it has been there in the more than 24 hours, then it is high risk. This is the target, and all the other features except risk is the features list that we have to train the model. We will split it, then we will scale it, because logistic regression would be helpful when we would be applying scaling. Standard scaling we have already learned about in detail in our past problems. Mm, train the model, train the SVM model, and then we are going to see which one is performing better. So let's get started. Huh. Handle. mm, I'll say step two, pre-process the data. We will do pre-processing by what? We will handle, drop the unnecessary columns. Why do we have any unnecessary columns? I don't think we have unnecessary. But let me. Oh, we have this unnamed column, right? We do not need this unnamed column, right? So we can data dot drop this unnamed column, and we have to drop the what? We have to drop this thing, which is drop this column. Let's see. Oh, we have to, yes, we have to drop this right in place. In place. Hmm. If I see, here we have this right. Okay, it has no name. It has no name, right? So I'll go to my CSV and try to look at it directly. It is this one. It has no name, right? The can I say this? I'm getting, so it has no name, right? Say I am getting this. No, actually the thing is different. So in the CSV there is no name. How can I just remove the first column? So it has no name, right? Okay. Oh yeah. Okay. So we have to include all the rows. So what I'm going to do here, what I'll do here, we are going to remove the first column as it is unnamed in the CSV file. So what we are going to do, we will do what? Data will be data. Consider all columns, so rows, and for columns, start with first column, and then we are going to print now. Data dot I location. Sorry. Yes, now it looks good. What we will do now, remove this, and we will handle. Go back to this code. Okay, fill the missing value of sim. I want to see if there is any missing value. So I'll say what print data uh, is null. Data is, where did we check is null? How do I check if these accounts have any missing value? If these accounts have any missing values, Yes, data. I need to first see, apply this on savings account. I need to check if this has any missing value. Is is null sum print, and we'll do what? Clean it, run it. It has 183 missing values. And what I will do, what if I do this? Here I can simply see the this has missing values and this has missing values. So I'll go and see. Uh, Check the count of missing values in data set. Uh, has has 183 missing values, and then has 394 missing values. So we'll do what? We will fill them. Data, uh, savings account, fill NA, fill NA, the missing values, fill them the missing values with, what do we have to fill in with? We have to fill this with unknown. We are putting unknown. Wherever it is missing, wherever it is null, we will put replace that null value with this string called unknown, and we will do in place. And then we are going to do the same on checking account. May replace it with an unknown and do it in place, and then we will simply see how the data looks like. We will go and simply check if it has any missing value. Now it has no such. I have added extra space. Now it has no missing values. Now we'll do what? uh, we'll do what? Convert. So if I want to see again, print data info, run this. While again we see we have sex is a categorical data, housing is a categorical data, savings account is a categorical data, checking account is a categorical data, and the purpose is also a categorical data. So we need to convert them into something, a numeric representation that the machine learning algorithm can understand. So we will do that. Convert the categorical uh, data columns into numeric using one hot encoding. Now we'll do what? So data will be, we will use the get dummy function of pandas library. Here we specify that we want to do what? We want to this apply this hot encoding on this data, and the columns I'm just going to copy the call list of the columns. So the list of the columns is same that just we have seen, and we want to do it this in place and the not in place. drop first. Yes, what we want to do. So one hot encoding does what we have seen it and understood it in past also, that it keeps the original column. Now we want to remove the original columns and replace them with their respective categorical columns. So yes, this is the new data. Now if I want to see how many new columns we have, I mean how many total columns we have, we should run it and we should see now we have 20 columns. For example, what one hot encoding has done, it has done sex males. Why? Because we might be having only male type of data in our data set, and then housing own, housing rent, saving accounts moderate, saving accounts quite rich, saving accounts rich, saving account unknown, checking saving. So this is, you see how it is converting it into converting the data, the categories into their respective own columns, like this sex male, right? So one hot encoding is also done. Now we are going to see it, right? Once done, we will do what? Create. Step number 3 is create a feature and target data sets. So we will do what? For that, first we are going to build. So that's what I was confused with. No, in the original data set, no column look like the target data set, so we have to build it. And what do we have to build it? What do we have to predict? We have to predict the risk prediction. We have to do risk prediction. So do not have any column representing the risk, right? So what we are going to do, we are going to come here and we are going to do what? Here we are saying, I'll say what is risk. Each person is classified as good or bad criteria according to the set of attributes. The link to the original dataset can be found here. Okay. So the we have to create our own logic for creating risk. So what we go ahead is that uh, if the credit amount is beyond 5,000 and is there for more than 24 hours, we call it as risk, right? So we'll do what? uh, Define a simple rule of generating risk column. That is, if the account has credit amount of 5,000 and the duration is more than 24 hours, it is uh, it is what considered a high risk. Okay, so we'll do what? We'll say create a new column called risk, and here we'll do what? The data, here the credit amount, which is of n type, is greater than 5,000, and and the data here, I need to first remove this extra space and make it a string, and then apply on the condition on duration is greater than 24 hours. Then do what? If both of them are true, and then we are going to convert the type, which is 1 or 0, into, which is, if it will return true or false, then convert it into true, right? Yes, type true. And then I'm going to simply see the head now. Let's run the script and see if we have created a new column called as risk, right? So yes, now I'll do what? I'll see how many values, if it has any risk, if it has anything, any, because all I see here, okay, this is a risk, this is a risk, but I still need to see the unique. So this risk has unique values, and then we will sum it. So yes, right, now it has, risk has both 0 and 1. Now we will do what? We will do what? Create features and target. So the feature is going to be all the columns except the risk column, and drop column wise. This is the features, and the target is going to be the risk. And let's see, x, this is our x, yes, and if you want to see our y, this is our y. Cool. We will go to the next step, which is step number 4. Split the data into training and validation data sets. So we will go with 80-20 ratio, as we have been going with all our previous problems. And mm, for validation, we will call validation by validation data. We will use, first we need to import the library. So library we will import from sklearn, from sklearn matrix, not matrix, model selection, import test, train test split, and use train test split, specify the x feature and the target, and the test size is 0.2, which is 20%, and the randomness state is 42, to make sure that whenever we are running it will produce the same output. And the step number 5 is build, no, scale the data. Before that, I guess we should scale later, right? We should be scaling it later. Okay, okay, exactly. So we do not want to scale this risk, right? So scale the data. Feature scaling. What we have to do? We have to feature scaling. So what, for that we are going to import a scalar, a vector, a scalar called sklearn dot preprocessing import standard scalar. What it does and how it does, we already know. It uses mean and standard variation to calculate the, to to recalculate the features, and their value then lies between 0 to 1, that is the mean lies between around 0, and the standard variation becomes around 1. So we have learned how it works, so we are now today just going to use it. Scalar, standard scalar, and here we will do what? We will fit our features, the training features, training data, and called as x trained, not x train, x train scaled. We could have applied with this before also, right? I guess we should apply it before. Mhm. S train scale, Y train. Let's keep it here. Scale, and here we will do what? Transform it using the same vector that we have created, and we will do what? Y train, not Y train. X validation scale. We have to scale the features, right? So here it is going to be X validation, and then step number 6, build and train the logistic regression model. So we'll do what? Import it first from sklearn linear model. Import logistic regression from sklearn linear model. Import SV. Okay, it is not. I was just giving you doing a hard test. From sklearn import SVM, SVC. Yes, we have imported everything. So, logistic regression model. Which model it is? Model logistic regression, and not here regression, and we will use logistic regression, and model dot we will fit on X train scale and Y train, and step number 7 is build and train the SVC SVM model. We have used this earlier also, so I'm not going to go in depth. So model SVM, SVC model SVM dot fit X train scale X, not Y train. Step number 8, make prediction and evaluate what? Logistic regression. So we'll do what? Here we have predict prediction, E V E L E, evaluate, EVALUA. Yes. So I'll do model logistic regression predictions. So we'll do what? Model logistic regression predict on X validation scale. Okay. And now we have to do what? We have to use metrics to evaluate how good the model is performing. So we are going to import the accuracy score, confusion matrix, and classification report. So we'll do what? Accuracy score, accuracy score of logistic regression, use accuracy score of the model of prediction made from logistic regression and the actual values, original values. Then we are going to have confusion matrix of logistic regression. Use the confusion matrix again, the prediction and the original value of logistic regression. Then classification report, we do that because we want to see the precision of call value, false positive and false negatives. Yes, classification model of the prediction and the original value. Then we will simply print it. I'll say logistic regression. It is, and then we will print accuracy. Accuracy score is accuracy score of logistic regression. Confusion matrix is confusion matrix of the the what the model, and then the classification report is going to be. I'm thinking of not plotting a graph today because we can, I guess, get the idea from the confusion matrix here itself from terminal. So classification, yes. Now we will have step 2. Let's write this code for step 9 also. Make prediction and evaluate the SVM model. And we will do what? Keep, I'll repeat it. And here we will do what? Um, Here it is going to be SVM prediction, or here it is going to be this logical logistic regression prediction. uh, Here it makes more sense, right? SVM prediction. So here SVM prediction, SVM prediction, SVM prediction, and this is the original value. Let's rename it to SVM accuracy score of SVM matrix, so confusion matrix of SVM, classification report of SVM, and here it is going to be logistic regression, and this we are going to print. And let's do what? Print this confusion matrix, print this confusion matrix, print this classification report, and yes, and I want to print this accuracy together, but confusion matrix in a new row, and this also in a new row, this in a new row, this in a new row, and here I'll say this is for the SVM model. So let's see how the model is performing, and if we are getting any error, we uh, line number 43 I have to see. Here here I have to do what? This is okay. Here I have to do what? X train and X validation, Y train, and then I think it should look good. So how this is how the model is performing. So our logistic regression is giving the accuracy of 96%. The SVM model is also giving the accuracy of the. Why so did I make mistake? Because I have used the same model. Here I have to use the SVM model to predict, right? Copy paste actually does not work. We have to use our own brain. So yes, the The SVM model is, so first decode the let's first decode how the logistic regression is performing. The accuracy is coming as 96.5, so 96.5%. It has predicted 175 as what as non-risk and 18 as risk. So 0 as not risk. Let's go back. So if it is 1, it is going to be risk. If it else, it is not risk. So we had non the value of non-risk items as 181, the value for risk items as 19. Do we have only, okay, so we have dropped the rest of the items, right, which were not present, right? So out of 181, it has correctly predicted 175, and out of 19, it has correctly predicted 18. So, and the ones that it has correctly predicted, that it has predicted 6 as risk, but originally they were not risk transactions, I mean account, and it has predicted 1 as not risk, but originally it was a risk. So this is missing here. This has performed really good here. And how do I know? Because it is 0 and 1, and I know what is 0 and 1. So here I can see it, and also from the code I can see it. If we go and see here, this is also performing something similar. So hmm, okay, so it has predicted what? Let's go. I'm a little bit confused. Maybe have I made any mistake copying the code? SVM prediction, SVM prediction, SVM prediction. SVM prediction is on the Y scaled, and the Y value scaled is this. X train, we have trained the model on this. Logistic. Acha, this is the total, and so here the false uh, negative is 0. Here the false negative is 1. Here the false positive has increased here. So overall, both of them are working really fine. So this is the total that was coming here. So I was mistaking actually. So I think the model is performing somewhat similar. Let me go and ask Chat GPT about it. This is how both the model has performed. For me, I guess both of them are performing almost similar. Huh. High performance with a macro average of 0. Yes, and around 96. Yes, both of them performed really well. Logistic Risk had better performed for risking credit scores cases. However, the SVM predict showed perfect recall for identifying high risk all risky cases, but it sacrificed some precision. So let's decode this classification report. The precision here is, so here for, like, it had here it could have performed better, the logistic model. And what it says for the risky uh, transactions. Uh, Out of all the transactions it has made or identified as risky, only 75% were true. So 75 times it was right. So it could have performed better here, and here also it did not work. So this also did not work here. But 100%, 100% here, 100%, 100% not. This, so this got better here. Here you see this is better, and there here our model is this SVM is working fine, better here. Here also the logistic is working, so both of them are working really well. But here, for identifying the risky cases and identifying the non-risky cases, the precision and the recall value is really good for the SVM model. So yes, conclusion. Both of them are effective model for predicting credit risk in the dataset. In choice between the two depends whether it is more important to minimize the false negative or maximize the true positives. Yes. Yes, so the problem is between these two. So do we have to minimize, this is false positive, this is false negative. If we have to minimize the false negative, then this. Maximize the true positives. True positive we have to maximize this. True positive we have to maximize, we have to use this as VM model. Yes. I think the data set is really small to finalize which of them has performed really well. So yes, and I think I still do need a little bit of more practice to decode the models. I do understand what each of this term makes. I mean, is used for, but yeah, maybe yes, this is one area that I have to work on. Some other time maybe, or some other day. So yes, this is how both the models are performing. Almost similar, 96%. We also understood the confusion matrix, and we also saw this precision, the classification report of precision and recall value. And we saw that here the classification for this, precision for this is better here than this, and but the false positives and this false negative, so true positives and are really good here in the SVM. Really, the margin is very less, and the recall value is also same. So these are the factors where they differ a little only. So let's commit the code. Commit it and code for day 29. Let's push it to main and see if we see the code. Yes, the code is here. Now I'll go and close it, the recording, and then you should be able to see this recorded video on the YouTube channel, and also you should be able to see the textual representation of it, textual form of it on my tech journal. So thank you very much.